Very happy to have you here for this webinar session. I hope you can hear me well. During this webinar, if you have any questions, please don't hesitate to interrupt me and ask any questions. If you have suggestions and comments, please feel free to go ahead and fire them at me. So first of all, let me introduce myself. My name is Arno. I'm a technical marketing specialist here at SimScale. And I have worked as a mechanical design engineer for the past few years, and I've used extensively CFD and FEA as a tool, as a simulation tool to predict behaviors of designs. I'm a part of the SimScale team, and I've run a lot of different simulations, especially in the architectural environment and the construction sector. So, who are we within the world and in the simulation world more specifically? So we've been founded in 2012, and our offices are in Europe, in Munich, and in the USA, in Boston and New York. We are really growing fast and hiring more and more engineers, account managers in all different departments. So don't hesitate to log on to our website and apply to the different positions we have across all the departments. There's a lot of different users worldwide, both in our strong hobbyist and community account, but also the professional and business part of our users. So there's a lot of different simulation projects you can access for free. A lot of different industries are touched, and you can obviously copy them and get inspired by them and get some input from them. There's a really very active website as well. You can participate and feel free to add your input. If you are an expert from a specific industry, please feel free to reach out to us to make any comments again. What I want to touch on here is that we've recently increased a lot our knowledge base and tutorials. So please feel free to follow along a lot of different tutorials we've recently created. And there's a lot of knowledge base in both CFD, FEA part in terms of preparing your CAD or your 3D model for import on the SimScale platform, post-processing result, and all different kinds of topic related to errors and best practices in general. I'll talk to you more about this in a few minutes. So what do we do? As I said, SimScale is a simulation platform including CFD, so fluid dynamics, in a wide range of topics. So construction, as I said, electronics, cooling, HVAC, and pedestrian wind comfort, which is a topic we're going to approach today. There's also a strong input on solid mechanics through finite element analysis and thermodynamics as well. So as I said, it's a simulation platform, so everything is accessible online. You have access to a wide range of projects and a huge computing power from the power of the cloud, obviously. So what we're going to talk about today is a bit of an extension to the first. It's a second part of a webinar I hosted a few weeks ago on the aerodynamics of building and the wind effect that these buildings create. So today we're going to touch base on new features we've added, which is called Porous Media. And Porous Media helps us understanding the effect that trees have as windbreaks on the flow development of the wind inside a city or any urban landscape. So we're going to explore a bit more on that topic and see that with this feature, we can really have a clearer idea of the impact of these trees on the comfort of pedestrian more specifically. Okay, so the workflow of today is basically how we're going to evaluate this impact of trees is to follow this workflow. So we're going to run simulations of the same model, but with one case with a tree and one case without a tree. without trees model, sorry. And processing the results, we're going to evaluate the differences between these two, the addition of this feature onto the wind, first the wind comfort map, and then as an extra investigation of a result, we're going to dive into the wind speed result and see why we have certain areas that are more affected by the wind comfort. So first of all, just as a recap from last time, what is wind comfort? So wind comfort here is a subjective measure on how well you're going to feel under certain wind speed. So a lot of different wind comfort criteria define different categories of comfort, as you can see, from sitting to exceeding. So not only we're assessing we're assessing a level of comfort, but we can also assess a level of safety, and that is particularly important for really high speed or areas that are subjected to cities that are subjected to really high speed wind. So why is it important? Like assessing the wind comfort is important when municipalities, architects, urban planners, or even residential planners, managers want to know if a specific area is going to be utilized. So, for example, will a shop terrace being under uncomfortable wind for people sitting on a terrace, for example, or if people pass by a certain street, will there be a lot of gusting? And or when you have a bus stop, will people be able to stand in that bus stop, or is it going to be uncomfortable for people as well? So I'm also thinking about bicycles, for example, that could be subjected to gusting, that could become a hazard, for example. So we're going to evaluate this through wind comfort categories and wind comfort map, as you will see in the results. How do we combat this undesired effect of the wind, this gusting and all this wind effect that can happen in cities? So we have two case scenarios. So either the building or the environment is pre-existing, and this is what we saw in the first webinar about aerodynamics of buildings. So the shape and the general layout of the building create a specific wind effect that we discussed. I've linked here a couple of articles, a couple of sources that explore a bit more different shapes and trying to show what is the best shape and what effect they create. So this is actually very interesting. Of course, there are in building design some strategies to mitigate the effects. So you see that we can create panels and canopies. We can orientate entrances in a different way. So this is what we saw earlier in the previous webinars, but today we're going to evaluate a scenario where the building already exists, but there is an issue with the wind development, and it creates undesired and comfortable location for pedestrians specifically. So what we can do, we can implement trees, as we can see here in this webinar, or we can implement urban furnitures or art pieces. And on the right-hand side, you can actually see one of the, it's a picture I took myself yesterday, cycling in Munich. And I found this very interesting that everywhere, if you look around, you can really see what are the strategies for architects to really implement methods that mitigate these the wind effects. So you can see that between these two towers, obviously, we can see that there could be a potential issue for the wind to go and to gust in between these two towers, and they've implemented a nice wind braking panel in the middle, just to prevent discomfort for pedestrians and passerby. This actually also acts as a noise barrier because there's a highway just right behind it. So I just found this interesting that everywhere you can actually see some method that have been implemented to mitigate these effects. Okay, just as a first introduction to trees, we all know that trees are important for the urban environment, for the cities, creating increased value for properties, participating in a better environment for the wildlife, for example, but participating in improved better physical health. I'm also talking about carbon emission, obviously, but also trying to implement more relaxing spaces as well. One of the major contributions to trees is that it can also mitigate the climate. So they will participate in making an area a bit cooler in summer, for example, or in winter, shielding a specific area from colder zones. So these are particularly important. What we're going to talk about today is how they're going to be impacting the wind flow, and therefore how do they behave as a porous media. So a porous media, what we call a porous medium, is a zone, a volume that is interconnected with different voids and more or less uniform. So there's a bit of a random pattern, and that creates a certain space where the flow really struggle to get in and out of. So for trees specifically, the porosity is really the ratio between how much void there is in this volume to the space they're occupied by tree branches, leaves, or stems, for example. So this is a good definition of the porosity. In this specific type of analysis, that we call pedestrian wind comfort, we are talking about a specific type of flow that we call LBM, so Lattice Boltzmann method, and we're going to approach the porosity through this approach with different factors. So, for example, why is it useful, and why do we need to approach the porosity of trees with porous media? Why can't we just model it? It would be very difficult, for example, to model the tree with individual branches, individual leaves. So we have to make this approach of over a certain volume, there is a certain value of porosity and inertial resistance to the flow. So this is very important to really predict how the wind is going to behave when it goes through these and past these trees, because obviously the effect, the flow pattern, not only one tree but a range of trees. So it's a very interesting approach, and a very smart approach, let's say, to calculate this and to get really meaningful results. You will see that in this example here, we can approach different type of trees. We can simulate the effect of different type of trees. So you'll see on the right-hand side, I've done a small analysis where I compared different porosities. So I'll show you in a minute how we can approach different porosities and see the effect on the flow pattern. So with certain type of trees, they will block the wind more than others. So to define this porosity in value, we have two different values. One is called the leaf area index. So this is the total leaves area over the total ground area. So how dense the leaves are, what's the density of leaves. It's actually interesting how they calculate this, how this value is being pulled out. They can actually chop down a tree and really accurately measure the density, the area of one leaves, and also calculate the amount of leaves there is on the tree. So of course, this is the destructive method, but there's also another method that is non-destructive, that measures the radiation intensity from the top to the bottom. I encourage you to read more about how this leaf area index is measured. So I will link you in the in the follow-up email that there are database in where you can find the leaf area index that defines the different types of trees. These are commonly available, but obviously what we did at SimScale is that we've predefined a couple of tree types, and we offered pre-selected or like a small library of trees. So you will see that we have a set, like I think 5 or 6 different types of trees predefined. But of course, you can create a custom tree with your own data and inputting the leaf area index and also the drag coefficient, which is defined by the ratio between the pressure difference to the dynamic force on the tree itself. So at this stage, we would love to hear from you. What type of trees would you like to have on the platform? Because obviously we want to make the tool easy for you to use, and we want to really implement the most meaningful vegetation and trees that are mostly used in people's job. So it's going to be very interesting for us to hear from you, from your input. Okay, so now what we've seen is that what you see here is that I've really simplified this approach. Every tree here you see on the right hand side has different porosity, as we said, different area leaf area index and different drag coefficient. But what I did is I had the same volume, the same size and the same volume for the tree. What I want to talk about now is how we're going to model the trees as a 3D model to be able to run this type of analysis, to be able to use this feature in a very meaningful way. So I think traditionally in construction software package like Revit or even Rhino, you could have the 3 models that resembles the one that you see on the left-hand side, which is really composed by 2 planar faces that are normal to each other, and that does not make a valid candidate for our LBM porous media feature. What we want on the other side is having a solid representation of the foliage. So the best approach is to have a really defined contour of what you think the shape is and the volume is, and it's completely or partly closed. The best is to have a complete pattern for closed volumes. In this on this aspect, yeah, try to be as close as possible to the original shape of the tree that you want to model. What I did in this particular case is that I left the trunk, which I think would be a nice thing to have and not really leaving it out. So the more detail you put into it, the better, I suppose. For our Revit models and Rhino models, I will also link a knowledge base article where we have explained how we can have all the trees of your model set up in one specific layer of your file, so that when you import it on SimScale, you will be able to select all the trees of your model in one click through one of the layers of the STL file that you're going to upload. So that is very useful, and it's very time saving. So let's have a look at one of the examples that we have. I'm sorry we are running a bit late on that, but I really want to show you a couple of examples here that we have. This is the pedestrian wind comfort analysis of the Grace Building in Bryant Park in New York City, and we're going to evolve to identify areas of discomfort, especially inside in the park, in Bryant Park. And we're going to see 2 different scenarios. As I said before, when I explained the workflow, one is going to be with trees and one is going to be without trees. and we're going to assess what the impact of the trees is on the level of comfort that is acceptable in the park and in the terrace of the New York Public Library. So we're going to have a look at this together. So you can recognize Bryant Park here that I took from Google Maps, and the tree shapes in the park. You can recognize iconic buildings. By the way, the Grace building that you see facing the park, the very tall building with a specific shape, is the Insight Partners building, one of our investors. So we decided to talk a bit about this because we found the shape of the building very interesting, and having this feature coming out from SimScale at this stage was very interesting to have a look at what's happening in terms of wind comfort in this area. So I'll show you quickly the setup. So it's very, very simple. First of all, obviously, you upload your CAD model as an STL file or 3DM file, Rhino file, or any other parasolid step file. You have a lot of different a range of file format you can upload your geometry to. You don't have to have a terrain, so it can be completely the zero ground with no terrain, but you can also obviously include specific topography. First of all, you define your region of interest in your simulation, the radius of what you are interested in, and define the north directions. The second one is define the wind rose. So you can either have your own data as a wind rose for all direction and the intensity of the wind all year long in the wind direction, or you can use our third-party provider MeteoBlue for importing automatically this kind of data, which comes very handy. And then the third one is going to be defining your pedestrian zones. As I said, you can take the ground floor, or you can select different surfaces. In this case, you see that I took the terrace of the New York Public Library. And the first one, which concerns our new feature, is defining the porous region. So as I said, you select all the trees and you assign it a type of tree leaf area index and drag coefficient. What you will need to do as well is define the average height of these trees. This is an extra input you have to add onto this feature. Okay, so once we have this, we can have a look at the result. It runs very quickly. So this one took about 2 hours to run. It's fairly accurate. You see that we have a lot of details in the results, and we can see left and right. On the left-hand side, what we have without the trees, and on the right-hand side, what we have with the trees. You can see the specific shape that the dark blue zones tell us is that where the trees are, obviously, we've improved the level of comfort by allowing category sitting long to be accepted in the area where the trees are, which you cannot see on the left-hand side, where only sitting short type of category is highlighted. So this is of course a good thing, but why is this happening? Like, what are the effects in the wind that contributed to improve this the situation? And this is what I'm going to show you now. So you can see here, when the wind comes from, for example, the south, I think it's southwest, the wind comes from southwest and really hits the facade of the Grace building, you will see a very big effect of the wind hitting the face, going downward, and then back against the main wind direction. And this is what we call the downdraft effect. I've already talked about it in the previous webinar. I encourage you to have a look at it and see a bit more in detail what we talk about in terms of wind effect on buildings. So a strong downdraft effect, sorry, that is mitigated when we have the trees on the right-hand side are represented by these volumes. So you can see that the wind will have this effect, but as soon as it hits the tree area, it's kind of stopped and really mitigate the effect and the high velocity wind at lower level. So this is the type of effect that trees can mitigate and that we can visualize thanks to the LBM solver and the online simulation. Second example, a little bit different. This is a nice model that I found online, and I wanted to really experiment this new feature, the pedestrian wind comfort feature, with a different layout than the one you just saw, with trees placed around pavement and in small parks. So it's a slightly different layout of city as well, different level of details as well, but it's going to be very interesting to see the impact of our trees. Okay, so this is a fictitious city. I found the model, as I said, very interesting because we had a lot of trees implemented in different locations. So we're going to see areas where it is important to have trees, when areas where they don't have such an impact, in which direction they are most predominantly affecting the wind as well. It's also very interesting. So diving into the results, you see left and right. The difference is even more obvious than in the previous example, where we can see that with no trees, you see that the area in the middle will have a massive walking fast kind of category that's highlighted in the middle. Implementing trees on the pavement in the middle zone where there is a small square, we can see that they really impacted the result. They really improved the situation by allowing lighter categories, should I say, of sitting long and sitting short. So this means that thanks to trees, we can have, for example, more secured parks and more comfortable to sit parks, for example, or terraces, or in any bus stops or shops or anything. So very interesting to see these impacts. These are, by the ways, you saw that in the previous example we had large volumes representing the trees, but in this example here, I implemented the trees that I first presented to you, where we have the trunk and we have the foliage. So these are exactly the trees that we first talked about when we talked about different types of trees. The type of tree that I've used here are a simple London plane tree, but you can also play around and use sycamore or different pine trees, or anything that you want to compare it with. Obviously they will impact the result to a certain extent. So here, for example, I found it very interesting. So we are in the upper part of our model, and you see on the left hand side, with no trees implemented, we see that the wind speed increases as it reaches corners. You see that at the corner of the of our building, it accelerates and create velocities higher than 10. And 10 meters per second starts to be uncomfortable for people to walk by. And for the same wind intensity and direction, on the right hand side, we can see that the trees have significantly impacted the result by mitigating this cornering effect, the wind that really accelerates around corners and accelerate between streets. So it's very interesting to see. You see that also the trunk. You can visualize the effect of the trunk on the flow pattern as well. So one example here, when the wind comes from left to right, and here from right to left on the other side of the model, where on the left hand side we have no trees, and the wind hits directly from the main street to the park, and creates a lot of high speed velocities of wind. And on the right hand side, it's really broken down by these porosities. So as a summary, I think I'm sorry again for turning up late with our technical issue, but I wanted to summarize this with you now. Is so we can simulate now with our pedestrian wind comfort type of analysis. We can simulate the effect of trees through our porous media simplification. it's a really interesting feature to have. It's a really significant asset to our analysis type. This will bring you more accuracy. This will bring you more meaningful result, I would say. So obviously, you can select different types of trees. You can create your own trees. There are a wide range, widely available library for leaf area index. I will link that also in the email, so you can have a look at huge database on different type of trees. If you have any suggestion of the type of trees you want to have, or if we made any mistake, let us know as well, of course. So we saw in the first example that the trees in Bryant Park were really impacting and improving the level of comfort in the park and on the terrace by breaking down this downdraft effect coming against the Grace building. And in a second example, we saw that when we implement trees on the side of the pavement, in corners or in small squares, we really mitigate the effects of cornering and channeling. So it really helps the result. And yeah, it's a very interesting thing to observe as well. So you can decide where you will be able to compare different cases, not only obviously I'm thinking about trees and no trees, but define the type of tree you want. So define a specific location, specific height, specific shape, specific type of tree. So you can compare all these different scenarios with SimScale, and you can compare them at the same time. You can run the simulation of all these scenarios of different geometries of trees, different layout of trees, but you can run these simulations, of course, with different multiple wind direction at the same time. You can run all these in the cloud at the exact same time and have the result within a few minutes or a few hours, and compare them also on the cloud through our post-processor, online post-processor. So this, for me, in my opinion, brings a lot of value into understanding what the wind layout and the wind development is in such cities. So yeah. All right, I guess this wraps up the session for today. Thanks a lot for having me today in this webinar. And feel free to ask your question through the chat of SimScale or through emails, and I will see you in the next session. Thank you very much and have a nice evening or a nice day.